Hello everybody, my name is Julian Andres Navarrete. I'm a geography student at Universidad Nacional de Colombia and a visiting scholar here at Purdue. Today I'm going to present a small project that I developed while I was taking a summer term course at the Earth, Atmospheric and Planetary Science department. The idea was to present the poster, but I cannot be in person in the summer symposium, that's why I'll present my poster virtually. So let's see it. The title is A Geographer's Perspective on Storm Chasing. Here I will describe briefly the SPOTTR course and some appreciations that I made in the middle. SPOTTR stands for Students of Purdue Observing Tornadic Thunderstorms for Research. The course is for students who want to learn about severe storm forecasting and observe tornadoes. The course focuses on practical learning of collecting data in a real scenario. As I wrote there, the course is organized in three main parts: theory of severe weather and instrumentation deployment, a field trip in Great Plains driving through several states, and a retrospective analysis of all the data collected. Here I show you some pictures when we were deploying a portable in-situ precipitation station near La Mesa in Texas. In this one, taken in Colorado, we were looking two outflow boundaries colliding between them and generating a very slow cloud rotation. This picture was taken in the north of Kansas when we were launching some radio zones. Now let's start with the geographer's perspective. With this map, I wanted to represent the fact that I noticed that the soil near Indiana and Illinois had a clear color, and in some soil profiles it was possible to see some layers of rock with soft textures. The soil had very fine particles which felt like soft dust or silt. That type of soils are common in lacustrine environments, and as that's a flat zone, it would make sense because it is known that the north of US was modeled by the glaciers. With deglaciation, there are remnant lakes which provide a tranquil environment to allow the formation of aggregation soils and rocks for long periods. Here we are talking in terms of geologic time. After the Illinois River going west, I appreciated some softened hills, and soil had a sandy texture, so grains were a little bit bigger and you could feel them with your fingers. And that area is in higher altitude than previous one, and soil have had longer exposure to the atmosphere. From Colorado down to New Mexico and west side of Texas, the area in red and purple shadow, soil is red, and you see gravel and sand. There was also possible to see some extreme volcanoes. The geomorphology there shows hills and flattened areas, but these ones are above 1,000 meters over the sea level. The slope is so soft that you barely notice the change. Also, there are some marks or scars in the relative low areas which allow to see the soil has a poor water retention, and since there's no vegetation or forestry, those marks are evidence of flash floods. This picture shows how we were tracking storms with weather radar images. In this map, I tried to condense some social aspects that I observed. The first idea I had in mind was to represent what can be affected and would impact communities. That's why in red dots I represent the turbine parks. When those are hit by tornadoes or strong winds can be damaged and consequently reduce the energy supply in some communities. The yellow shape shows susceptible areas to be flooded, as I described before. During the field trip, we saw some floods, the purple shapes, which were blocked in some ways. In one occasion we had to turn back and find another route because it was impossible to go through. Sometimes way lanes were reduced due to the same reason. Blue shape represents narrowed highways with not enough traffic signals and with low visibility. We drove by at night. There it was a storm and visibility was low, only we had the car lights. Sometimes we barely could see the cars coming. Not to have traffic signals made stressful the journey. Those elements are relevant because when there is a tornado, emergency or whatever, communities are advised to evacuate or find shelter. Those areas might have obstacles to mobility, increasing the risk to have fatalities. Or even worse, could be an accessibility obstacle to rescue or emergency brigades. Now, the pink and green circles represent cities and towns we visited or passed by during the field trip. Cities as big as Lafayette and West Lafayette together have organized emergency systems with hospitals, firefighters, police, and tend to be bigger than 150 square kilometers are those in green. Those cities concentrate relatively big populations which can be affected by tornadoes and strong storms, but as they have emergency services, they can make face to adverse situations in a fast way. Pink circles are showing small towns which barely had station police. There were small communities, and in most of them, houses and buildings were old. Some seemed to be partially abandoned, and I could not appreciate health services or something like that. But most of them have small airports which would make relatively easy arrive there with health equipment when needed. The resilience conditions of those towns vary from state to state. In the south of New Mexico and Texas, poorness in communities was evident. It means they do not have enough incomes to recover by themselves after a disaster. Those elements were in my mind while I was passing through those towns. Again, there are some other things to talk about, like permanent bubble gas layer between New Mexico and Texas due to gas petroleum exploitation. It should at some point affect people's health. But okay, let's continue. In this picture, the Mesonet man is showing us how weather researchers adapt trucks to collect data and protect vehicles from giant hail. This picture is showing one of our daily morning meetings to forecast weather and decide where to go to storm chasing. Here, as a personal suggestion, to this course, I consider it would be great to have thematic summers and interdisciplinary approach. It means take advantage of dead times while waiting for a storm to happen or after launching a radio zone, and have discussions about geomorphology, infrastructure evaluation, or social perception of risk, or even history associated with weather events in places where students are. Sometimes students would like to know more of context around them. I consider that would enrich the learning process and let students remember and associate tools deployments and weather observations with contextual events. As a conclusion, I just can say the SPOTTR course entirely worth the pain. Dr. Tanamachi and Dr. Dawson do a great job, and after the course students have a better idea and good understanding of forecasting storms and do storm chasing safely. Finally, I want to give thanks to the IPS head department, Dr. Sitso. He believed in our work and helped and provide economic resources to make this course possible, and for sure, thanks to Professors Robin Tanamachi and Daniel Dawson for their dedication in the course and with the students.